All right, let's discuss hybridization. Let's look at the concept of hybridization. Please copy down. Carbon with just one double bond, half. Carbon with just single bond are sp cube hybridized. Carbon with just single bond are sp cube hybridized. I say when it comes to hybridization, please note, please, number one, carbon with just single bond are sp cube hybridized. Next up, please, carbon with just one double bond. Carbon with just one double bond are sp squared hybridized. Carbon with just one double bond are sp squared hybridized. Should proceed. Next up, please, carbon with two double bond, carbon with two double bond are sp hybridized. Carbon with two double bond are sp hybridized. Now hold on. Is it possible for a carbon to have two double bond? Yes, it's possible. How? Let's explain two double bond concept. If I have a carbon this way, this carbon is having two double bond. It's possible, right? This man, of course, we said we know that double bond signifies alkene. So this one here is a higher form of alkene. Now the concept, we said one double bond is what? Sp squared. Two double bond are what? Sp hybridized. So I'm having a two double bond. Does this man exist? Yes, it exists. When we look at the concept of diene much more later, it exists. Now, is this man balanced? Of course, no. 1, 2, 3, 4 balance. 1, 2, 3, 4. This man is not balanced, right? So if I have to name this, what do you call this? This is called prop 1, 3 diene. This is called prop 1, 3 diene. So look at diene much more later, a higher form of alkene. So I'm saying that two double bond, carbon with two double bond are sp hybridized. Finally, carbon with one triple bond or carbon with triple bond are sp hybridized. Carbon with triple bond are sp hybridized. All right. So note the hybridization pattern of a single bond, double bond, and a triple bond. In essence, a single bond is an alkane, double bond is an alkene, two double bond a higher form of alkene. Triple bond is what your alkyl group. So alkyne, right? So alkane, alkene, alkyne. Right, that's how it works. So single bond signifies alkane, double bond alkene, triple bond alkyne, and etc. All right, so I have this concept here. Let's proceed, please. Note the following, please. Note the following, please. Note the following, please. Note the following, please. In order of electronegativity, please, in order of electronegativity, note that we have P first, P less than SP cube less than SP squared less than SP less than S. It's not just SP cube, SP square, SP. There's one that has P, only P. There's one that has S, only X. So note that it's not just SP cube, SP square, or SP. There's one that has SP, one that has just only X. This is called the order of electronegativity. If I'm to ask you, what electronegativity? It's simply the ability of an atom to accept or receive electron. That's all, please. So I'm saying in order of electronegativity, I have P, SP cubed, SP squared, SP, and X. In exam, they will ask you, list out the hybridization in order of electronegativity. Start with what? P before SP cube. Not just SP cube, SP square, and SP. It starts with what? P first before SP cube, SP squared, SP, and then X. This is what we refer to as the order of electronegativity. With this concept, let's now solve some past questions. All right, sample problem is sample problem. Let's look at some sample problems. Indicate the kind of hybrid orbital. Indicate the kind of hybrid orbital used by carbon. Indicate the kind of hybrid orbital used by carbon in the molecule given below. In the molecule given below, and state the geometrical of the bonding. And state the geometrical of the bonding. And state the geometrical of the bonding. Copy this down, please. All right, please copy this example down, please. Keep this example pending. Let me explain something, please. I omitted something. Let me keep this in here. Now, listen, please. When it comes to hybridization, please. When it comes to this concept, there's what we call shape of molecule. Please note that when it comes to shape of molecule, there are about three shapes. The first one is called the linear. It's called the linear, or you call it planar, right? Planar. Number two, we have when it comes to shape of molecule, there are three. The first one is called linear or planar. Number two is called the triangular, right? This one is called the tetragonal, or you call it a tetrahedra. So when it comes to shape of molecule, you'll be asked to, for instance, they'll give you a molecule this way. They'll ask you to tell us that this molecule, which one is SP squared, which one is SP cubed, that is, state their hybridization pattern, and also tell us the shape of the molecule. So bear in mind that there are three shapes. The first one is called linear or planar. Number two is called the triangular. Number three is called the tetrahedra, or you call it a tetragonal. By the word linear, it's a shape in this form. Bear in mind, by the word triangular, something of this nature is a triangular. By the word tetragonal, something of this nature, please. bear in mind that for tetragonal, you have something of this nature, please. These are like shapes of molecule. We'll look at this concept as we proceed with this example. So I'll clean up this part for solving sake. So bear in mind that we have three shapes of molecule ranging from the linear or planar. Next up, we have the triangular and the tetragonal, or called a tetrahedral. All right, so let's start with this problem, please. Number one there, for A, let's solve question A. I have H2C double bonded to O. I'm asked to state the hybridization of this top here, of this molecule. The hybridization here is what? This one is single bond, and we said this man here is a double bond, and we said one double bond is what? Sp squared hybridized. So this compound here is Sp squared. I'm done. Next task, I'm asked to state the geometric of the bonding, that is the shape of molecule. So the shape here, what is shape here? To determine the shape of any molecule or a compound, draw the structure first. I have C, this is C, double bond to O. Of course, I have H2. That's, of course, I can put in anywhere I want. H2, this 1, 2, H2. So this is C, double bonded to O this way, and then H2. I have this. Now draw the shape. Of course, cover it up. Something of this nature. Observe. This shape, when I drew it earlier here, is a what? Second type of the shape. That's called a triangular. The shape is what? A triangular. This is a triangular. Sorry. Trigonal. Please, it's called trigonal. Please. Trigonal. Please, not triangular. It's triangular. Please, triangular. Please, triangular, please. So it's called triangular, not triangular. It's called triangular. So this is a triangular shape. So I'm done with A. Let's do B. For B, I have H3, CCl. So first, let's state the hybridization here. Of course, I can see that there's nothing here. So this being nothing here signifies an alkane. So it means, if I draw this structure now, I have C this way. Chlorine is here, that's Cl. H3, 1, 2, 3. This man is a single bond. That's an alkane. An alkane has one single bond. So I'm saying that an alkane, this man being an alkane has a single bond. So for one single bond, I have Sp cubed as the hybridization. So this man here, the hybridization of this molecule is diazation is of course Sp cubed hybridized. The shape of this molecule, the shape, of course, you should tell me the shape here, because I can something of this nature. A tetragonal. This man should be a what? A tetragonal. As you can see, this is a what? A tetragonal. Tetragonal, right? So that's like the name to that's like the two names we're asked to give for each compound, or you call it tetrahedra, a tetrahedra, right? That's A, B. Let's do C and D. All right, for C, I have C O2. Please, for CO2, this is how you draw the structure. So I have two oxygen, that's CO2, that's C, then O, then O. Please, for CO2, that I draw CO2, please. So this for CO2. A CO2, the hybridization here is of course what? sp. Why? Because we said two double bond are sp hybridized. Two double bond are sp. So this man here is sp, right? So let's start here. The shape, this is a what? A linear. So the shape, the shape of this molecule is of course a linear, or we call it what? Planar. So this man is a linear or planar. All right, let's do D. Finally, let's do D. For D, I have HC triple bonded to N. For triple bond, a triple bond is what? sp. So the hybridization here, the hybridization for this molecule is what? sp. Why? Triple bond. Next up, this shape is what? A linear. So the shape here is of course linear. Linear what? Planar. You want to. So this is linear. So this is what we have to find. We have to name the hybridization pattern for each compound and also state the shape of the molecule as we just did now. Let's take another example, sample problem 2. Let's get this done, please. So we're asked to find, the question says, please copy down the question, please. Copy this down, please. It says that indicate the hybridization, for this one here, it says indicate the hybridization pattern for the carbon atom in the compound. That's all. So now observe, please. Indicate the hybridization pattern for the carbon allotted here. For A is triple bond. If A is triple bond, what's triple bond? sp. This man is sp. B is what? A single bond. Single bond is what? spq. spq. C is double bond. Double bond is what? sp square. This is sp square. This is how I solve this particular question. Let's solve this, please. All right, that's basically the concept behind hybridization and and how to identify the shapes of molecule. See you in the next class where we'll look at the concept behind types of reaction. Before we go, do well to like this video, share to your friends and classmates. Also do well to visit my website at www.ganiyuabubakar.com. In my website, we have close to over different courses for JAM students and WAEC. We also have for a full course for beginners for organic chemistry. If you're interested, you can go to my website and order for the course. If you're finding it difficult to get to my website, do well to reach me out through my WhatsApp number. Also, I just launched a book called The Shortcut to Academic Success, which I really explain a lot on how I succeeded using this technique and method. If you're interested in learning or applying the same idea I used, the book will be shown behind the screen here. If you're interested in buying the book, you can do what to reach me out through my WhatsApp number, or I'll drop a link that will take you to the payment directly. It costs just 1,000 naira for the book, so it's very cheap, so you can go and afford the book. All right guys, see you in the next class, and welcome to Excellent Link Academy. Do what? Subscribe, very important, and also leave a comment and share to your friends and classmates.